Okay, here's 4.3. It's called writing equations of parallel and perpendicular lines. So first off, the symbol for parallel is kind of looks like an 11. It's two vertical lines like that. The symbol for perpendicular looks like this, kind of like an upside down uppercase T. All right, so I'll be using those sometimes. So parallel lines are two lines that never intersect, and we've got these two little sets of arrows to indicate that these are supposed to be parallel lines. And they're going to have the same slope. Parallel lines always have the same slope. Okay. Perpendicular lines are any two lines that form a right angle, like these two, and they're not going to have the same slope when they intersect. Perpendicular lines are going to have what's called opposite reciprocal slopes. Okay, and I'll talk about what I mean by that. So let's just say that the slope of this line is 2/3. Okay, so the opposite reciprocal of 2/3, well, since this is positive, I'd want the opposite reciprocal to be negative. That makes it opposite sign, okay? But the reciprocal part means that we take the fraction and flip it upside down, okay? So those would be opposite reciprocals, okay? All right, so let's look at this next example. Determine which lines are parallel, if any. So here we've got a graph. So you could use the slope formula here, but when I have a graph, I like to just count the rise and run. So let's look at line A at the top here. So to get from this left point to the right one, I'd be going up 2. So that's my rise, and I'd be going to the right 6 units. 1, 2, 3, 4, 5, 6. Yeah. Okay, so line A here. Well, here, I'll put the slope right here. That's going to have a slope of 2/6, which is 1/3 when I reduce it. Okay, now let's look at this one. Let's see, we're going up 2 again, and then we're going to the right 1, 2, 3, 4, 5, 6, 7. So this is going to have a slope of 2/7. And I can't reduce that. So those two, even though they look parallel at first glance, they're actually not. They're not quite parallel, okay? And then this last one, let's see, we're going up 2. 1, 2, 3, 4, 5, 6, to the right 6. So that one has a slope of 1/3 as well. So the top and bottom lines there have the same slope, which makes them parallel. So that would be line A and line C. So down at the bottom here, I'm going to write that. Line A is parallel to line C, okay? All right, for the next example here, we could graph these and do the same kind of thing, count, rise, and run. But when I don't have a graph, I like to use the slope formula so that I don't have to draw one. So the slope formula, I'm going to use the coordinates to find the slope. And in the numerator, you subtract the y's. In the denominator, you subtract the x's. Here, let me separate this here. Okay, so let's find the slope of these lines. Let's start with line A. So let's see. I'm going to do -1 minus 3 for my y's. And then on the bottom, I'm going to do -6 minus -5. Whoops. -6 minus -5. Okay, I got a double negative there on bottom. On top, it's just going to be -4. On bottom, that's going to be -6 plus 5 then. So I get -4 over -1. That's going to be +4. Okay, so that has a slope of 4. Let's check the other two lines. Okay, line B, we'll do -7 minus -2 for the y's, and 2 minus 3 for the x's. So that's going to be -7 plus 2. 2 minus 3 is -1, and I got -5 over -1, which is +5. So those two are not parallel. Let's check line C. Okay, -5 minus -1 for my y's, and then 0 minus -1 for my x's. So that would be -5 plus 1. And then the opposite of -1 is +1. So I've got -4 over 1, which is -4. Okay, so none of those have the same slope, so none of them. So my answer here is none. Okay. Yeah, those are opposites, but that's not going to work. That because a positive slope would be going uphill, a negative slope would be going downhill. So those two are not going to be parallel. Okay. All right. And then we're going to do the same kind of thing looking for perpendicular lines. We need to find the slopes. Now it's really clear looking at this picture that these two are not going to be perpendicular. But A and B might be perpendicular. It kind of looks like a 90-degree angle, and those might be perpendicular. So we still want to find the slope of all three lines. So let's go ahead and do that here. So looking at line A, we're going to go down 2 and to the right. So -2 would be my rise. I'm going down 2 and to the right. Let's see, 1, 2, 3, 4, 5, 6, 7. So this one is going to have a slope of -2/7. Okay. All right, let's do line C. I'm going down 2 again. I'm going to the right, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, and then let's find the slope of line B. So I'm thinking, okay, I'm going up 1, 2, 3, 4, 5, 6 units, and to the right 2. So the slope of this one then would be, 6/2, which reduces to 3. Now looking at these two slopes are opposite reciprocals. So yeah, you can't, this isn't a fraction, but you could write it as 3/1. And then if you flip it, it would be 1/3, and take the opposite, -1/3, right? So if you think about flipping this and changing the sign, it'd be positive 3/1, which is 3. So these two are perpendicular. So that's lines B and C. So down at the bottom here, I'm going to say that B and C are perpendicular, like so. Okay. All right. So one more here. We're checking for perpendicular lines, and let's use the slope formula again. So here I'll write the slope formula here again. Or you could graph them, but I think this is going to be quicker here. So let's just find all three slopes. I'm going to have 3 minus 4 for my y's for line A, and then 4 minus 0 for my x's. So -1/4. Okay, let's try line B. 8 minus 7 for my y's, and -2 minus -6 for the x's. So that's going to be 1 on top, and then I got -2 plus 6. So it's going to be 1/4. Okay. All right, let's find line C, sorry. 9 minus 5 for y's, and -5 minus -4 for the x's. So on top I've got 4. On bottom that's -5 plus 4. So that gives me 4/-1, which is -4. Okay. So opposite reciprocals. So that means one of them would have to be positive and one would be negative. So these two definitely aren't perpendicular. Okay. And if you look at these, yeah, they're opposites, but they're not reciprocals, right? You haven't flipped the fraction. So these two are the ones that are going to be opposite reciprocals. If you take this and flip the fraction, that would give you 4/1, and take the opposite of that, -4/1, which is -4. So my answer here, lines B and C are perpendicular. Okay. Okay, on the next page, we're going to start writing some equations of lines. So first, we're going to look at writing an equation of a line that's parallel to a given line. Okay, and some basic steps. We're going to find the slope of the given line. Okay, and then we're going to write an equation for the new line, what I call the new line. I call the old line the given line, so this would be my old line on this problem. The new line is the one I'm writing the equation for. So I'm going to write it in point slope form using the slope and the through point. So you'd have to be given a through point. Like on this problem, I'm given that my line goes through the point 2, -5, okay? And then if asked for slope-intercept form, convert the equation by isolating y. And you might have to do some distributing to get rid of parentheses as well, okay? All right, so let's try this out. So I'm calling this my old line here. Y equals 3/2 x minus 7. That's my old line, okay? And then this asks for slope-intercept form, so I want my final answer in that format. I got to keep that in mind, okay? And then it says it's parallel to this old line, so my new line is going to be parallel to that one, okay? So what I'm going to do with this old line, if I can find the slope of this old line, that will give me the slope of the new line. Remember, whenever you're writing the equation for any line, you need the slope. So they're either going to give you the slope or they're going to give you a way to find it. And here the way we're going to find it is using this line. So this is already in y equals mx plus b form, which is nice because then I can see that the slope is 3/2. And that's all I really need from this old line. So now I know the slope of this is going to be the same. This is also going to have a slope of 3/2. Okay, and I'm thinking, what else do I know about the line that I'm writing the equation for? And the other thing I know is that I've got this through point. So I know this goes through the line, the point 2, -5. Okay, so let's start writing an equation for our new line. I'm going to think about, well, you could actually go straight to y equals mx plus b form if you wanted. I said to go to point slope form first, so let's stick with that. So I'm going to look at point slope form, which looks like this. Okay, and then what I'm going to do is plug in 3/2 for the slope. Okay, and I'm going to use this through point as my x1 and y1. So I'm going to do y minus -5 here. Okay, and then x minus 2. All right, so I got a double negative, so let's change that into a positive. Y minus -5 is the same as y plus 5. Okay, and now I've got an equation written. It's just in point slope form, and I want my final answer to be in slope-intercept form. So I want to get rid of the parentheses first by distributing 3/2. Okay. And then I've got -2 times 3/2. Well, -2 times 3 would be -6. So this is going to be -6 over 2, right? Because if you're thinking about it's 3/2 times -2 over 1. So a positive times a negative will be negative. I got that now, okay? And then 6/2 reduces to 3. So I can write 3/2 x minus 3. And now I want to isolate y. It's almost in y equals mx plus b form. I just want to subtract 5 from both sides. And now I've got y equals 3/2 x minus 8. Okay, and mission complete. All right. All right, very similar problem here. Just some new information. So we're again looking at parallel lines. So this time the old equation is 3x minus 4y equals 24. Okay. When we put and then it's going to be parallel to my new line. So I'm going to use the old line to find the slope of the new line. So I need to find the slope of this. Unfortunately, this one isn't already in y equals mx plus b form. So I'm going to play with this equation and rewrite it in y equals mx plus b form so that I know what the slope is. Okay. So I'm going to start by moving 3x. So I'm going to subtract 3x from both sides. Okay. And now I have -4y equals, and you could write 24 minus 3x. Those aren't like terms, so you can't combine them. But I'm going to put the -3x in front of the 24 so that it's closer to y equals mx plus b form. Okay. And then I want to isolate the y, so I'm going to divide by -4, and I've got to divide the entire equation by -4. Okay. So then I've got y, and then a negative over a negative would be positive. So I could call that 3/4 x, and 24 divided by -6 would be -6. Okay. Oops, I'm off screen there a little. All right. So all I need from this is the slope, and now I can see the slope is 3/4. Okay, so that tells me that the slope of this line would also be 3/4 since they're parallel. Okay, and then the new line that I'm writing the equation for, I also know it goes through 1, -2. Okay, Now, I'm asked for y equals mx plus b form, but first I'm going to write this in point slope form because I don't know what the y-intercept is, but I do have this through point. So I have a point and a slope, so that lends itself nicely to point slope form. Whoops. Okay, I started to write y equals mx plus b. But here we go. Okay, so I'm going to plug in these three things. So my slope is going to be 3/4. And then here's my x1 and y1. Okay, so I'm going to do y minus -2 and x minus 1. Okay, got a double negative there again, so let's change that to a positive right here. And then I'm going to start distributing to get rid of the parentheses because I want to convert this into slope-intercept form, right? So slope-intercept form doesn't have parentheses. And 3/4 times -1 would be -3/4. Okay, and then I just need to isolate the y, so I'm going to subtract 2 from both sides. Okay, so I've got 3/4 x minus 3/4 minus 2. Well, I can actually combine these, but first I'd want a common denominator, right? So since the denominator here is 4, I'd want this one to have a denominator of 4 as well. So I'm going to multiply this by 4 over 4. So now I have y equals 3/4 x minus 3/4 minus 8/4. Right? Because you'd multiply, they think of this as -2 over 1. If you multiply straight across, that's what we get. Now we can combine those and get our final answer. So -3 minus 8 would be -11. So I've got -11/4 there. Okay, last page. We're going to do the same kind of thing, except when we have perpendicular lines. So there's a little twist to that, okay? So we still, when we're writing an equation of a line perpendicular to a given line, we still want to find the slope first off, okay? And we're going to find the slope of the old line here, that would be this line. And then I'm going to use that to find the slope of the new line. But remember that the slopes aren't going to be the same. They'd only be the same for parallel lines. The slopes of perpendicular lines are going to be opposite reciprocals. Okay, and then write an equation for the new line in point slope form using the slope and the through point. Okay, and then we're gonna, if you need slope-intercept form, you're gonna convert the equation by isolating y. Okay, all right, so let's try this out. So my old line here is this one, -2/3 x plus 2. Okay, my new line, that's the one that I'm writing the equation for, is going to be perpendicular this time. So I'm just going to put that symbol in there to show, okay, I'm going to find the slope here, but then I got to remember these are perpendicular, not parallel. So this is already in y equals mx plus b form. That makes it a lot easier because I can just see the slope there is -2/3. Okay, and then I got to think, I need these to be opposite reciprocals. So I'm going to flip this fraction and change the sign, which would give me +3/2. Okay. So my new line, I also have this through point. And that's, I'm going to plug both of these things into point slope form. This is going to be my x1, y1. Okay. So let's go to point slope form now. All right, so let's see. My y sub 1 is -3, so I have y minus -3. Then 3/2 is the slope, and x minus 2. Okay, got a double negative in there, so let's change that to a positive. Okay, and then I want to convert this into slope-intercept form, so I don't want any parentheses there. I'm going to distribute to get rid of the parentheses, and then I'll also isolate the y after that. Okay, so -2 times 3/2, that's going to be -6/2, and that simplifies to -3 there. Okay, so a lot of times I'll see people look at these and say, oh, those cancel each other out, but actually to isolate the y, we want to subtract 3 from both sides. So it's going to be -6 there, right, at the end. So it's going to be y equals 3/2 x minus 6. Okay, so just be careful with those. All right, let's try another. So these are perpendicular again. My old line is 3x minus 4y equals 12. And that's going to be perpendicular to the new line. All right, so we got to find the slope here again. This one is not in slope-intercept form, so let's put it in slope-intercept form so that we can see the slope. So I'm going to subtract 3x from both sides. I'm isolating the y, but I want to sneak the negative 3x in front of the 12, like that. And then I'm going to divide everything by negative 4 to isolate the y. So then I've got y equals 3/4 x minus 3. Okay. My slope then is going to be 3/4. Okay. If these are parallel lines, then my new slope would also be 3/4, but they're perpendicular, so I got to remember to use the opposite reciprocal. So I'm going to flip the fraction, change the sign. That would be negative 4/3. Okay. The other thing that I have for my new line is my through point. So again, that's going to be x1, y1. And now I'm going to plug things into point-slope form since I have a point and a slope. Okay. So my y sub 1 is negative 1, so y minus negative 1. My slope is negative 4/3, that goes there, and then x minus 3. Okay, got a double negative, so let's rewrite that as a positive. Now I want to get rid of the parentheses by distributing. Okay, negative 4/3 times negative 3. Well, a negative times a negative is positive, and 4 times 3 is 12, so that's going to give me 12/3, right? Think of this as 3/1, so 4/3 times 3/1. You multiply straight across to get 12/3. And then 12/3 reduces to 4. Okay, and I've almost finished here. Just subtract 1 from both sides. And I've got y equals negative 4/3 x plus 3. All right, that is the end of the section, and I'll see you next time.